So this is going to tell us two separate answers. When the graph hits here, but also when the graph hits back here. But that's not where we care about what's going on in the parabola. We care about where it's being hit on the positive side, because there's no way it can hit on the negative side because we don't really have a negative distance in mathematics. Typically, although when you get to physics, you talk about negative distances representing a direction going back versus forward, but typically in the real world, we say there's no negative distance. So we're not going to do minus square root of 24 because we know that would make that negative. So we're only going to do 4 plus the square root of 24. That is an approximation of 8.899. So that is about how far away the marker will hit the ground from me. The marker will travel 8.899 feet horizontally. Specifically horizontally, right? Because it's also made distances vertically, but really all we're talking about is the horizontal change that it's made. The marker will travel 8.899 feet horizontally before hitting the ground. Okay. If Megan makes the trash can at the back of the room, which is 2 feet off the ground, how far will the marker travel horizontally? So now we're changing this perspective and we're saying, okay, we've got this parabola and it's leaving at a height of 4 feet, right? So like I probably like chucked it from here. And then it's going to stop at a height of 2 feet. And I want to know when my y value is 2, what is my x value? So I can even say that x equals question mark when h of x equals 2. All right, which means that we're setting this guy equal to 2. 2 equals negative 1/2 x squared plus 4x plus 4. I believe you have all of the tools available to you in order to solve for this. If you would like to solve for it by hand, remember it needs to be set equal to 0, or else you cannot solve it. It has to be set equal to 0, or else the null factor property does not work, right? A times b equals 0 results in us saying either A equals 0 or B equals 0. So if it's not set equal to 0, the entire process goes out the window. It has to be set equal to 0. All right, solve for it on your own. What we get is x equals, let me actually change that to an approximation symbol. X is about 8.47 or negative 0.47. Again, we are not going in the negative direction. We're only talking about your positive value. So that's how far it traveled horizontally before making it to the trash can. Okay, last problem. Mark Watney needs to create a rectangular garden in the Hab on Mars to grow potatoes. For those of you not familiar, this is The Martian. If you still don't know, take a look. It was originally a book, and then they made a movie out of it. But it's a scientist who's stranded on Mars, and he has to kind of figure his way out and build things and use his engineering and his brain in order to make Mars habitable for himself. So he intends to use the wall of the Hab as one side, and he has 100 meters of material to build the other 3 sides. Find the length and the width that maximize the area of his garden. What is the maximum area of the garden? This is a typical critical thinking, higher level question that I think is so cool. And not only is it used in situations like this, but it's also used in optimizing volume with a limited amount of surface area, right? When you only have so many materials, like Mark Watney, he only has 100 meters. How can he best utilize that 100 meters to get the largest area he possibly can? And it does make a difference. So what we're going to talk about first, we need to prepare for this, because I'm sure most of you are like, I have no idea how to begin this problem. the first step is always draw a picture. Draw a picture to represent the situation with real-world applications. A hab is some sort of like space house, so I'll just represent it like that. And then we're talking about a rectangular area, not my best work. Thank goodness for erasable pens. We're talking about a rectangular space here that we're talking about the perimeter of their three sides. We know that this side and this side would be equal, and this side would be a different measurement. And so I've chosen to represent those lengths with variables that are the same to represent that they are the same length. So when we have 100 meters of material, that means that all of this represents that 100 meters. So go ahead and take a second and think on your own. How would you represent the equation of all of this being 100 meters? Well, if we're talking about 100 meters of material, we're talking about the fencing of it. In other words, the perimeter. But it's not the entire perimeter, it's only these three sides. That's a good way to optimize the materials that you have, is use something else in order to be the other side, right? That would be a smart way to utilize that. Which means that x plus 2y or 2y plus x equals 100. Okay, so I have dealt with this. That's all I've done so far. I haven't even thought about the area. I've just started to represent what I know visually and then mathematically in some way, but I'm not done. I need to move on to the other thing, which is we want the length and width that maximize the area of the garden. And then what is the maximum area of the garden? So then we need to talk about how do we find the area? Well, how we find area is we multiply each side, x times y. We want to maximize x times y. When we are maximizing an equation, we're talking about maximizing the y value. So think about this for a second. We want to maximize this, which is the y value. Actually, let me do something else here. Let's not use x and y because talking about things like x and y values could then make it confusing. If I talked about this as like b, b, a plus 2b, and we want to maximize a times b. Okay, so we want to maximize the equation of a times b. So then the equation of a times b really is y equals a times b. And I know that right now some of you are probably thinking, but that's three variables. We don't really talk about three variables. And you're right, we don't. In order to make this something that we want to handle, we need to only have two variables. And right now we have three, y, a, and b. But I have another equation here. And this other equation includes things with a and b. So what if I if I isolated for a variable and then substituted it into this other equation, it would eliminate the second variable. I could either turn b into an expression in terms of a, or I could replace a with an expression in terms of b, and then it would only have one variable. So take a look. If I take this guy and isolate for a, I would get a equals 100 minus 2b. So then I can take this and say, well, this a and this a are equal. They are the same. That is why I'm using the same variable. Only ever use the same variable in one equation when you're trying to talk about the same measurement. So that means that if these two are the same, that I can plug this expression in for a. So I can rewrite it as y equals 100 minus 2b times b. So now I've taken this equation that represents the area of my plot and represent it as a quadratic. Sorry, spoiler alert. It is a quadratic because once I distribute that b, it becomes 100b minus 2b squared. And now I have an equation of two variables. I can use this equation to figure out what is the maximum area by finding the vertex. Go ahead and find the x and y value of the vertex for this equation. So your vertex of your equation ends up having an x value of 25 and a y value of 1250, resulting in the point 25 and 1250. Now, you already have one of your answers here. That answer is here, your maximum area, right? Remember that y represents the area of your garden. And so you found the maximum y value. It is this. The maximum area is 1250 meters squared. The dimensions, we have solved for 25 for B. We have not, however, solved for A. So we just need to really quickly subtract out 50 from 100 to solve for A. 2 times 25 is 50 minus 100 minus 50 is 50, so A is 50. So the dimensions are 25 times 50. 25 is B. We just needed to solve for A in order to get the final dimensions. But those are the dimensions of our maximized area. Good job.